Hello students, after the discussion on the sum of the equations of haloalkanes and haloarenes, now let us do some problem. It's a textbook question number 22. Question is, what happens when the conditions are given here, first, second, third, fourth, fifth, sixth and seventh. So you have to go through the conditions given, and on the basis of that you have to complete the equation. That means here the equation is given, incomplete equation is given in the form of words. So you need to make the equation for this. So let us do one by one. First one is N-butyl chloride is treated with alcoholic AOH. So first of all, because it is given in words, you need to make it into the equation form. So what is given to us? N-butyl chloride. N-butyl chloride is treated with alcoholic KOH. So first of all, make the structure for N-butyl chloride. That is the structure. N-butyl. N means the chain is actually the straight chain, then only it called as N-butyl chloride. That means it is no branching here. Butyl chloride means there are 4 carbon atoms, that is 1, 2, 3, 4 carbon atoms, and Cl is on the first carbon. That is N-butyl chloride. And alcoholic KOH. Alcoholic KOH, the presence is given alcoholic KOH here. So what will be the reaction? So we have learned two types of equation of this is halide. It is an alkyl halide. Alkyl halide. We have learned two type of equation, that is one with alcoholic KOH, and other with we have learned with aqueous KOH. So two equation you have learned with the alkyl halide, with alcoholic KOH and aqueous KOH. So when there is a reaction with aqueous KOH, at the time the reaction is called as a nucleophilic substitution. It is a nucleophilic substitution. But when the reaction is with alcohol, then the reaction is called as dehydrohalogenation. Dehydrohalogenation, or which is called as butyl elimination reaction. So especially when the reaction is given with KOH, you have to look at the condition, it is alcoholic or KOH. So what is given for us? Alcoholic KOH. So you need to apply this equation, that is dehydrohalogenation reaction. So let us solve this. So dehydrohalogenation, that means the removal of beta hydrogen and the halogen group. So first of all, you need to identify the beta hydrogen. From here, alpha, this is the alpha carbon and this one is the beta carbon. So beta carbon have 2 hydrogen. So we can remove one of the hydrogen, because here there is only one beta. This is gamma. There is only one beta carbon. So there is only one possibility of formation of product. Here the halogen group, that is this halogen group, and one H, that is beta hydrogen, will get removed. So the rest of the portion you will be going to write as it is, that is CH3. I am writing CH3, then CH2. Look at on the structure which is given in the reactant side, CH2. Then here because one hydrogen is removed, so how much hydrogen left here? That is one hydrogen left. So we can write CH. Next, because this is an alpha carbon, this is a beta carbon. So I told you during this there is a formation of a double bond, and the double bond is formed between alpha and beta. So you can say here double bond is formed. Then what is left here? CH2. because the Cl is removed, so we are not going to write this one. So what we got here? We got an alkene. We got alkene. So particularly when you name this alkene, in the question, if it is asked to give the name for the product, you need to name it. So what is this one? This one is 1, 2, 3, 4. That is butene. So we got the product here, that is butene, due to the dehydrohalogenation reaction of N-butyl chloride. So let us check the answer. So what you got here? That is but1ene. That is the answer we got here. So in this way you will be going to do such a question. Next one, that is bromobenzene is treated with magnesium in the presence of dry ether. So first of all, identify the reactants here. What is given to us? Bromobenzene, that is a haloarene. It's a benzene, that's it as a arene. And magnesium. So reaction with the haloarene with magnesium in the presence of dry ether. So if you remember, we have learned this one, reaction of alkyl halide or aryl halide with the magnesium give rise to formation of Grignard reagent. So let us do this equation. Make the structure for bromobenzene. How you make the structure for bromobenzene? That is, on the benzene ring there is one Br, that is bromobenzene, plus Mg in the presence of dry ether. So if you remember, I told you to learn the general equation which we have done for the case of alkyl halide, that is Rx plus Mg give rise to RMgX. This I told you to learn it. The same way you can apply here. In the place of R, what will be having? Benzene. In the place of X, we have Br. Now this is our product. Now you apply the concept here. R is our benzene ring. Our R is a benzene ring and X is a Br. So when you make the changes here, what you'll be getting here? That is, R is the benzene ring. Then Mg. And what is X here? X is Br. So what we got? C6H5. In the place of benzene ring, we can write here, that is C6H5 MgBr. We can write C6H5 MgBr. That is called as a Grignard reagent. How you name the structure? What is C6H5 here? C6H5 is called as phenyl. So we can call this phenyl, magnesium, and this is bromide. So how we name this one? Phenyl, magnesium, bromide. So the answer is clear to you. That is phenyl, magnesium, bromide. That is a Grignard reagent. So you can check the answer here. So what we got the answer here? That is phenyl, magnesium, bromide. So whatever the question is given for the case of Grignard reagent, what you need to do here? You need to keep one Mg in between. That is the simplest way to find the answer. You can easily make the structure of the product. How? Just keep Mg in between the Br and the carbon of benzene ring. You just have to keep a magnesium. So that is the answer. It's very simple equation, Grignard reagent. Next equation, chlorobenzene is subjected to hydrolysis. It is subject to hydrolysis means the reaction is a nucleophilic substitution reaction. So nucleophilic substitution reaction of chlorobenzene. Chlorobenzene is a haloarene. So as we have discussed, nucleophilic substitution reaction of chlorobenzene, that is haloarene, the reactivity is lesser in compared to the alkyl halide. So that reaction, hydrolysis reaction, that is the reaction with the NaOH in the presence of temperature, pressure, and the presence of H plus, what it gives rise to? Nucleophilic substitution takes place. So you have to identify the equation first. So this equation is nucleophilic substitution reaction. So what we get the product here? Substitution means, substitution I told you, remove the halide part and keep the nucleophile here. So this is the new halide, remove this part, and the nucleophile, that is OH, you have to keep in the place of Cl. So what will be the product here? So product will be the benzene ring. I told you this part will be as it is, only you are making the changes at the halide part. So the rest of the portion will be as it is. So this is ring, and what we have here, Cl. In the place of Cl, our substitute OH comes, that is OH. So the product will be this. I told you during this reaction it takes place in two steps. In the first step there is a formation of an sodium phenoxide, then only the product, this product takes place. Since in this equation both the terms, that is first and second terms, it is together given, so you need to make the final product. In between product no need to write. So let us check the answer for this. So what you got the product, that is phenol. So you can check the answer and the reactant. What is the done here? In the place of Cl, now OH is there. So that is phenol. Next, reaction of ethyl chloride is treated with aqueous QH. Identify the reaction. You have learned lot of equations. So which equation is applicable here? Alkyl chloride, that is alkyl halide, treated with KOH, particularly aqueous KOH. Aqueous KOH means, I told you the two cases are there. Alcoholic KOH means dehydrohalogenation reaction. Aqueous KOH means the reaction is nucleophilic substitution reaction. So you have to do nucleophilic substitution reaction. Let us make its structure. Ethyl chloride, that is ethyl group means C2H5. Chloride means Cl. Now it is treated with the aqueous KOH. Aqueous KOH is treated with aqueous KOH. So we need to make the product. So how we do this one? It is a nucleophilic substitution. So remove the halide part and keep the OH here. So you have to keep OH in the place of Cl because it is a substitution reaction. So what will be the product? The product will be the rest of the part. This is the rest of the part, C2H5, and in the place of Cl you have to keep OH. So we got C2H5 in the place of Cl. Now we have substituted OH group. So we got a alcohol. So this reaction is a nucleophilic substitution reaction in which the nucleophile is substituted to a halide group. Now let us do next question. Methyl bromide is treated with sodium in the presence of dry ether. So this is a name reaction called as Wurtz reaction. Let us do this equation. What is given to us? Methyl bromide with sodium. So let us do this equation. This is a Wurtz reaction. Just identify the reaction first. So it is a Wurtz reaction because here there is a reaction with sodium with the alkyl halide. So first write down the general equation. General equation which we have learnt is, that is R X plus twice Na plus, I am writing this in the reverse order, X R. Now there is a breakage of the bond. Which bond break? This bond. CX bond, that is a polar bond break. Here also polar bond break. And there is a formation of side product. Better make the use of boxes in this way so that you can be easily frame the product. Now what is remaining here? One R is remaining here, one R is remaining. So what will be the product here? The product is R. So that is, I told you, it's the doubling of alkyl group. You can see that the alkyl group, the R is here, it is doubled in the product side. So now let us apply this general equation in the problem which is given here. So in the problem it is given CH3Br. CH3Br, so this we have taken as R, this we have taken as X. So what is R from here? You can identify what is R. CH3. CH3, that is a methyl group, is the R. So in the product we are applying R is CH3. So CH3 is the product. So we got the product here, that is 2 carbon alkane, that is ethane. So what is the product here? Ethane. So it is very simple to do such type of reaction. That is a reaction, a Woods reaction. You need to do just a doubling of the alkyl group. So the alkyl group, because this is the alkyl group, you need to double it. So how we double it? CH3 is the alkyl group. Write it once again and keep a bond in between. So this is the quite easier way to make the product. So let us check the answer. So you can see that we got the product ethane plus twice NaBr. Next one. Methyl chloride is treated with KCN. Identify the equation methyl chloride. Methyl chloride, that is alkyl halide, treated with KCN. So you have identified the equation. Which reaction is this one? KCN, that is CN is a nucleophile. So it is a nucleophilic substitution reaction. So nucleophilic substitution reaction, I told you, remove the halide part and keep the nucleophile. So do this problem. How we will be doing this one? So CH3Cl, that is methyl chloride, plus KCN. KCN, as I told you, CN is a which type of nucleophile? It is an ambident nucleophile. That means it can bind either through C and it either can bind through nitrogen. So KCN, in the case of KCN, the product will be cyanide. So, but in the case of AgCN, the product is isocyanide. So when you make the product, so what you need to do? Substitution reaction. That means the Cn is taking the position of halide. So what will be getting the product? That is CH3. In the place of Cl, we are writing Cn. That is a cyanide product. But if it is given AgCN, in the time this product will be NC, that is isocyanide. So let us check the answer. So here the answer is methyl cyanide. Methyl cyanide is formed because of the nucleophilic substitution reaction in which the halide part is substituted by the cyanide part, Cn nucleophile. So we got this product CH3Cn. So when you compare the product with the reactant, what you can find? In the place of Cl, Cn is there. So we got this product, that is methyl cyanide. So similar type of questions you need to practice it. So first of all, whatever the given sentence is there, make it into the equation form as we have done in all such cases. And for this it is necessary to know the making of structures, because when you make the formulas, equations, then only you can do the reaction. So all of you do these questions in your notebook. Thank you everyone.